Can you see me as well?
Yes, we can see you. Yeah, please go ahead.
All right, perfect. Thank you. All right. So welcome all for this second day session. The session is predominantly we are conducting this on Design Explorer. The nature of the session is that we are keeping it to only 30 minutes, so it's quite short. The idea behind this is we want that people to grab what is there new, and then if you are further interested, what we can do is we can have a specific session, in-depth session we can do it. Okay, that's the plan of this session. So today's session that I have planned is on the Design Explorer. Okay, so Design Explorer is a completely new ribbon which sits inside of your Hyperworks. Okay, so let me turn off my camera so that you can just see the presentation. Okay, so this completely new, brand new Design Explorer you can only see in Hyperworks next generation tool. The reason behind that is it's completely new and it supports the newer architecture, and that's the reason it is there in your Hyperworks X or next generation. So if you want to explore your Design Explorer, then you will have to use Hyperworks X or a next generation. Okay, it doesn't support the classic. With that, I'm just moving on to the okay, perfect. So agenda that I have for today is I'll be talking you to what this Design Explorer is, what is it, who is it for. Then we'll quickly take you through some of the explorations that we can do, how we can populate them, evaluate those explorations, interpret them, and finally some of the new tools that we have embedded into this are AI and ML. Okay, so we'll take a look at those. But let's address the first question: why we are coming up with this called as a Design Explorer. Okay, so the first reason or the inception of this tool is that imagine if since we all are CA engineers, and essentially that happens that once you complete your CA process, you come to a point where you look at the results and then quickly it comes to your mind that, okay, if I want to improve my design, I have to work on these variables or these parameters, for example, the thickness, or maybe I have to do some changes in the shapes so that my design can be improved. So if you want to do that, the next step is you are going to do that one by one. So that's where we thought, like, why can't a CA engineer can quickly do a multi-run by himself, right? So there are definitely tools which are in depth that will take you to the next level, but then without leaving the Hyperworks environment, if you can do the multi-run, DOE or optimization, how would that look like? So that's the inception of Design Explorer. That's how we started with the Design Explorer. So you have all the bells and whistles required to perform a DOE and optimization. So from starting from setup to the execution to interpret the results is something that you can do with the help of Design Explorer. Okay, quickly where it will help you to gain insight into your product performance. Those are all real-time performance predictions you can do. You can do trade-off studies without any solver runs. So that's one of the advantages. And then just like the people who know that there is a tool called as HyperStudy, but this is not HyperStudy. So we have brought some of the tools here so you can dissect your data and look at it, different ways which are important to improve your performance of the product, right? So you can do all of that. Then finally you can run the optimization as well. Okay, so it's a complete package and it will help you step by step, and it starts from left to the right. Okay, and the main advantage is you don't have to leave the Hyperworks environment, number one. Number two, you can upfront see on the screen which are the design variables and how you are variating those, right? You can quickly do that. And one more, finally, it is solver independent. Of course, we play very well with our own solvers like OptiStruct or Radios. However, if you have any other solvers, you can register those solver scripts and then you can go ahead with any other solver as well. Okay, so that's what is Design Explorer. So to give you a glimpse of that, what I thought is I can directly jump onto the demonstration and show you what exactly it is. But before doing that, I just would like to show you the problem that I'm attempting in this case. So this is the one. This is a engine cradle model, okay, which is at the front. You can see this is the model that I have taken to do the DOE, especially. Okay, when I run this base analysis, I have done the three different setups in this. Number one, normal mode analysis. I have FRF for front torsion load and the front bending loads. Okay, so if you can see, let me turn on my laser pointer. So you can see at around 89 hertz, I see a velocity around 7.94, and in the bending mode at around 400 hertz, I see the velocity is around 19.34, right? So something like this, and I want to optimize this one going further. Okay, so this is what I want to do. So my design variables. So let me jump into the product itself and take you through. So as you can see, this is how your Hyperworks looks like, and you can see that Design Explorer is something sitting over here. Okay, so once you go to the Design Explorer, you have this all tools available to you. So as you know, with newer Hyperworks, you can directly drag and drop your model, which I'm doing that. It's asking me to change the OptiStruct. Yes, I'm changing it now. With that, the model is available on the screen. Okay, so as I said, in my model, I have these three load steps. One is normal mode, front bending, and front torsion. And I'm taking the velocity at these nodal locations. Okay. With this, I'll just directly start ahead with my design exploration. So I know that these are the outcomes that I have just now, which I showed. So to start an exploration, you have three sections. Number one, here you start an exploration. You give your inputs over here. These are nothing but your design variables. This is a section where you go ahead with the responses that you want to add. Then finally, if you are performing an optimization, or if you want to put some constraints on your targets, you can do it over here. And finally, evaluate. So this is where you evaluate, and also you can explore your results. Okay, so let me quickly start with this. So I'm just saying, okay, let me start the design over here. Exploration. So first step is you click here and say whether you want to perform a DOE or an optimization, right? So you just say that, okay, this is what I want to do. And it asking me where I want to have the locations where this needs to be done. So I'm just saying that this is Design Explorer. Okay, so that's fine. I'll just say, so this is my working directory, study path, where all the studies will be kept, right? So that's it. So this is what you define, and you can open this exploration. You will get a completely new tab that opens up. So whatever the changes that you do, you will see over here. Okay, now I have given that as a DOE. I'm doing it. So I'm just going with gauge optimization. So I'm just selecting all this. Okay. So one thing I know for sure is I had done assembly over here. So I'm just saying, okay, isolate that assembly itself, and I'm going to the gauge and selecting all these properties. So the moment I select all these properties, you will see that there is a micro dialog pops up, which is telling me that how you want to define the lower and upper bounds. So by default, it is set to 10%, and it is coming in terms of percentage. So maybe I'll say it's 20%. I want to bump it up and down by 20%. If you want to change it to bounds and you want to give the specific values, you can specify the bounds over here, or you know for sure that it is a thickness discrete values that you have, you can go ahead with this and discrete, and even you can do that. So right now I'm just saying, okay, done. So you can see that all these 10 different design variables are generated in one shot, right? Similarly, I have some shapes also created in this. So I'm just going to the shapes, and you can see I have these two different shapes. So I'm selecting and said, okay. You can see that those are the shapes over here. And what are the values that pertaining to these? They are given over here, right? So suppose I want to change this particular shape or this shape. So you can see -1 to +1. Even if I want to change that, I can directly change over here. I say, okay, -3 to +3. That means 3 units, it will be going up and down, right? Yeah, so this is how I have created the design variables. Quickly, you can even see how they look like and what are the things that you selected, right? For example, I can quickly go here, go to the details, and this is where you can see all of these things. For example, I can just go ahead and choose here. You can see that it will show me keeping everything in gray. This is the thickness that I'm working with. I can just, change this and you can see the thickness varying over here, right? Similarly, if I want, I can go and look at the shapes. So the shape that I want to change, right? So these are my shape variables, right? So you can quickly see that. So these are the things that I can do with the help of Design Explorer. Once you have done and defined your input variables, you can quickly move on to the responses that you want to track. So in my case, I'm tracking the mass in this case. So I say mass. If I want, I can completely select all the properties, or what I can do is I can just say apply. So it essentially takes all the properties in place which are there. Okay, let me just say show all. Okay. Now with that, I'm tracking the displacements in here. So I can go to the displacement target. So in this case, if you saw the velocity in torsion and the velocity is in bending is something that we saw in the slides, right? So I can go here and I can track these velocities, right? I can just say, okay, this is the node I want to track. So once again, your macro dialog comes up, so you can click onto this, and if you want to do some changes, you can do that over here. So suppose I'm saying so velocity underscore torsion load, and then I can choose the load conditions over here. Front torsion, right? I'll say it's a front specifically so that I know. And in this case, I'm looking at the response at particularly maximum z direction, right? And the frequency, something I can specify. In here, it was somewhere 89, right? So I'm just saying, okay, till 100. And that's it. So you can see it's over here. I can go ahead, select once again. In here, I'm saying velocity, bending, front, choose typical load that I'm looking at again, choosing that load in the Z direction. In here, I'm looking at between 300 to suppose 450 because we saw the values there, right? So this is where I'm saying this one, and that's it. I'm done with that. So you can see these are the responses. I can add frequency responses also if I want. I'm just saying, okay, maybe I want a frequency for maybe mode 7 because that was a mode 7 there. So I'm just saying, okay, this is what it is, normal modes, and I want 7th mode, right? I'm done. Similarly, I can just say right click on this one and say duplicate. The same here, I want to look at mode number 10, and let me set this to 10 here. So I'm done there. Okay. With that, we are kind of done over here. Mass, and we have two velocity and two modes also. Okay. And if I want to apply some constraint, I can go here and say click constraints, select the response from here. So velocity, torsion, front. This is what I want to put some target on. I'm saying that, okay, upper bound maybe for this one should be 7.5 in case it was somewhere 7.9, I guess. So I'm just choosing this one. Another response, I'm going with the bending, choosing that, and I'm saying my upper bound for this is around velocity as 19. Done. You can see those are the constraints that I've defined over here. Even for the frequencies, if I want, I can just quickly go here and say this is the mode number 7, and for that because I don't want the frequency to go beyond a certain level. So I'm just saying that, okay, for mode number 7, I want 87.9, and then another one, mode 10. So for mode 10, I'm saying that it's around 394.9. Okay, that's it. I'm kind of set over here. With this, I can generate, I can go ahead with DOE, or I can do an optimization as well. But right now I have set it up for the DOE, so I can go ahead, I can go to this evaluation tab, and this is where I can run it straight away. So you have different DOE types. So by default, it's set to MELS. Then if you have another solver you're chosen, so you can choose from here if you want. Multi-execution, if you want, you can specify over here and say export and run. So in the interest of time, I have already run this. So let me quickly go to this one. Okay. And what I'm doing is I'm clicking onto this result explorer, and with this, my result explorer opens over here. So it shows me all the runs that I have done over here. Okay. So you can click onto any of this, and quickly it will show you the deformation, what is happening actually with the changes with the model. Or you can straight away go ahead and load the result also if you want. You can quickly load the result, load the plots, or even you can compare. So you can compare with your nominal run, or you can add which run that you want to compare. So I can say, okay, I want to compare with this one, 28th. So if I choose 30th and I say, okay, so you can see I want to, it can compare both of the results. Okay. And then quickly you can see how it is, run 28 and run 30s are something that we are looking at. So you can see that my design variables, what are the first value and what are the second value. Okay, so for all these design variables, you can see quickly what happens, right? So that's what the comparison you can do. With that, I'm moving on to the linear effects chart. That's a new tab which is there. This is nothing but your Pareto plot that we call it as. So it is showing you which is the most significant parameter, right? So if you have so many design variables, out of these, which ones are the most significant when it comes to the response of velocity in torsion, right? So you can see, I can say that the most significant is this one if I have to work with the torsion, right? And then there are many over here. So that's what it is telling you, ranking from the most significant to the least significant, right? So these are the design variables with respect to velocity. If I want to change with the in bending, so it is telling me that, okay, these are the ones, and there are these as well. They affect, but they affect, these affecting in a positively, these are affecting in a negative way. Meaning to say that if I want to reduce this one, then I should be increasing this, or vice versa, right? So that's what it is telling you. Then the third piece of information that you get after you run the DOE is you can do a trade-off studies. What do I mean by that is, without running your solver, you can quickly know, because at the backside it is even studying that model. So when I change something over here, for example, I can change and you will see the values changing over here. Okay, these are the scalar values that you are changing. Okay, so you can see what is my velocity, what is my bending velocity, what I'm getting. So these are the things you can always go back and forth. You can put it to maximum and see what is the value that you can get, or you can go ahead with the minimum and see what the value that you can get, right? So that you can do. So that's a part of a trade-off. So you have, even for that matter, scatter plot if you want to plot specifically velocity, okay, with okay. Now what this essentially does is it'll open up your hypergraph, right? So, and it is showing me what are these values. Okay, so basically each dot tells you that that's individual run actually. So you can see with respect to these what values I'm getting, right? So you can turn on and off and you can do that. Now One more piece of information that I want to tell you about is you can do the clustering as well. So I have a better example to show you. So I'll switch to that example. But before that, I want to even talk to you about field prediction. So these are the two most significant parts of your Design Explorer. Definitely, you can do this one. Now let me go back to my run over here, which I did the initial run before I running. So suppose I want to quickly start my optimization study over here. So what I can do is I can straight away go here, add, and I'll say I want to perform, an optimization studies over here. Now with that, you can quickly see here, I can directly select all of this and say select and then turn on all this. All these parameters can be taken into for optimization. Now, since you ran the Design Explorer for the DOE studies, so if you feel that, okay, these are the only ones which are significant and maybe these are not the ones that I want to take it, so I can leave them out, right? So that's an advantage of it. So after you have performed the DOE, you can run the optimization with fewer design variables so that it converges much faster, right? So that's how you can do. Okay, let me go back to my presentation and quickly show you what the results that I got over here. So we saw the effects chart, main effects chart, nothing but your the linear charts, and then we saw the trade-offs, how we can do, and the scatter plot. Now you can, if you run the optimization, it will give you one output specifically, and you can take a look at that and you can plot. So it will give you one outcome, and directly you can load this and you can take that run specifically. Now with this run, you can see that we were able to achieve the targets that we have. I'm not just loading over there. So here you can see we have reached the targets that we wanted. Now let me quickly go, okay, and show you an example of field prediction specifically. So for the field prediction, I'm using this case a B pillar side crash specifically. So I have my design space already defined, responses I have defined, and the displacement is something that I'm tracking that one, and I have run the DOE particularly. Now since you have done the DOE, so you're set. So what I'm going to do now here is, let me go back to my session here. I have loaded it already. One thing that you saw is you're able to track over here, but another thing is you have an option called as generate FP report. This is nothing but your field predictions report, and you can turn on specifically which are the labels or the outcomes that you want to predict. Now, for example, in this case, what I have done is I have selected displacement and I have trained my model. Okay, now, and I have clicked the predict. So you can see this is the result it is showing me. Now, as soon as I do some changes over here, you will see the changes happening in my results here as well. And this is real time. And this is superimposing on the model itself. You can see, or if I just minimize that, what is the deformation or the displacement that I would get when I have these values. And even though if I don't have the results for this is what it is doing. It is giving you that. Okay. So that's about field prediction. Now let me quickly go back and show you one more last piece of information. So this is the one information that I wanted to talk to you about. Okay. So we looked at this trade-off studies and all, but there's another one piece of information that you can obtain easily from this Design Explorer is clustering. So for this example, I'm choosing a crash rail, so which is here you can see, and this is the problem that I've taken. And in this case, what we have done is we have run the DOE, but at the same time, for the people who are from the crash background, they know for sure that I need a deformation in a specific order, in a specific fashion, right? So this is where it helps you. Now, first thing, definitely the first piece of information that you can get is the linear effects chart. Definitely it will tell you that the most significant one to least significant one. Then the second one is trade-off studies you have done, and finally the DV comparison. You can do that comparison. But one more thing that you can do with this is a clustering. So for example, let me quickly run this one. Okay. So as you can see, once I am there in the result explorer, I'm choosing the clustering portion, and I can quickly load the results for the clusters. So it is basically telling me based on the deformation. So by default, you can see that it has come up with two clusters. So based on the runs that I have done, and with respect to the displacement, I see two clusters. Okay, which are these two clusters? Now maybe you can even add, but by default it has taken two clusters. You can add. So you can see these yellow dots. This is one cluster, this is one cluster, this is one, and the green dots, this is a fourth cluster. So it will tell you these are the designs that I need to look at particularly. Okay. Now for example, you can see that if I choose in the cluster 2, which are the runs which are falling in this range? Which are those runs? Okay. That's what it's telling you. And now when I load all of them together, so you can see, okay, you can see the animation, right? So the deformation, based on the deformation, maybe this is what I may look or want, or maybe this one. So you know from the field that what kind of displacement that you want to look at, right? So that those are the ones. Suppose if you're looking at a cluster 1, so that's the one from which you can choose the design, right? So based on the displacement, it has done the clustering basically. Okay, so that's a crash rail. So the example. With that, I'm coming to an end. So if you have any questions, please type it in the chat window. We'll take it later. And if you want to register your solver script, you can always go ahead and you can, if you have any different solver, you can always go and choose this one. It will take you to the different solver. With that, I'm concluding my session. If you are interested, please feel free to let us know. We will get back to you and we can conduct an in-depth session. Thank you. Thanks all.
Thank you. Yeah, thank you, Anjali. Thanks.
Thank you, everyone. Have a good evening.